Hey there, here we are, almost winding up this whole little boot campy thing. We're in an area called pointers and reference, and this is a good C++ lesson. And it's not something you're going to get right away. Sometimes people get it like that. Conceptually, it's a really cool thing to be able to do when you're programming is have access to memory, and that's what C++ does. It gives us this wonderful access to memory and hardware. We can get close to programming to the metal like C in assembly, but a little bit easier for us to do. So let's talk about pointers and reference and what they are and how we use them. And you're going to see a lot of these in C++ because this to me is what I think C++ is so cool about. So here we go. Let's get to these things really quick. First off, what is a pointer? Now I mentioned pointers a couple of times during some slides here or there. So now let me explain it a little bit more in detail. Pointers are just variables. And that was our second time we ever chatted. We talked about variables. So it's just a variable, right? And what does a variable do? It holds a specific data type, right? Well, the pointer, they just hold memory addresses. So they hold memory addresses. So and that's awesome because now we can go directly to that memory address. It allows direct manipulation of the memory location, and that's super cool because it points to that memory address. Now, a pointer has a long lifespan during your program, and one single pointer can point to many different ones during the lifetime of your program. So you can declare a pointer and have it go all over the place, and that's really cool, like when we build linked lists later on in algorithms or data structures. And they're super cool, and they're great because you can allocate new memory. We can build memory on the heap and outside of the stack, so we can actually build memory and expand and speed up processes. So it's a really cool thing. Pointers are just awesome. So let's get on it, what they are. And we talked about that they're just a variable. So back up to our very first one that we did, or our second thing we talked about. It's the exact same syntax, except you have the asterisk next to the variable name. So data type, when I said it holds a memory address, it holds the memory address for a specific data type, right? Because if you're going to look into a memory address, you're looking for a specific data type. So this integer is a data type. We know that's a whole number. This is an integer pointer. It only holds memory addresses for integers. And the name of my integer pointer is PTR. I can declare this pointer, but not assign value to it. So that's kind of cool. I can assign value later. If I want to assign value because it only holds memory addresses, right? Remember, if you have an integer x and you make integer x equal to 0.335, it can't do it because that's not a floating point number. And that's a floating point number. You have an integer. So here we're going to use a thing called the address of operator. And this is going to give us our reference. So now if we have the address of, it allows us to assign value to the variable pointer because the ampersand and the num means address of that variable. Okay? We'll do some examples. Promise. If we have something stored, if our pointer is pointing at something and that variable grabs it, what is it holding on to? The memory address. What if we want to see what's in the memory address? We have to dereference it, right? Because if we're referencing the memory address, we have to see what's inside the memory address. So the pointer is pointing at a specific memory address. And this memory address is x325z. Okay, now pointer holds that value. If I just see out pointer, I get this value. But if I see out star, that says, okay, what's inside of pointer? What's inside of this memory address? And if there's an integer in there, it's going to say, oh, 10 is inside this memory address. So that's what we call dereferencing. Because the pointer just gives us this, but if we dereference it, we get to see the value that is inside the memory address. You're not as excited about pointers as I am, but that's all right because we have pointer arithmetic. right? Because we can go to a memory address. Now this applies, we're going to make this apply to an array, because we know an array is a continuous block of memory. Truly an array is just a single pointer, but you'll get to that in like, again, this is not a comprehensive thing. So we have index 0. If I use to find the memory address of this array, foo, we'll call it. If I go and I want, hey, I want the memory address of this array. Now we know when we allocated this, we got foo is going to be size 5. So now it's a continuous block of memory. So if I just say, hey, I want the memory address of foo at index 0, and then that'll give me that. So now I have the address. If I want to see what's in it, I'll dereference it. But what I can also do is add on to my pointer, or the name of my, what my variable name is. And if I want to see this right here, using pointer arithmetic, I can do ptr plus equals 3. Now, okay, 0, 1, 2, 3, and it's just going to show me what's in that index. So because I can increment across using pointer arithmetic, the pointer can move memory addresses. That's exciting. That's really cool. And again, you probably won't be dealing with a lot of pointer arithmetic to start, but the longer you go, the more you will. Now it gives us a thing for dynamic memory allocation. We're going to get more into this with classes. But what this is if you're coming from a Java background, you know the keyword new. Now we're not creating a new an object here. All we're doing is we're allocating memory out on the heap. So we have stack and heap is the big block of memory that your computer has. And when we want to allocate outside of what's called the stack, we have to go out into that memory. And then we have to say, hey, I don't want you on the stack, right? I want you out on the heap. I want you in a different memory location. So because there's more memory out here and we can dance around and do some really cool things. So we're going to say initialize our pointer, integer star pointer. The name of our pointer is ptr. And we're just going to say go create new integer. That means go out and find memory, 4 blocks of memory out in the heap, x3. Right? Go find that. And now we know where it is, because pointer can always point to or find that memory location because we built new. Here's something that C++ has that we have to be aware of. The more you get into it, the more this is important. You have to deallocate the memory that you just took from the heap. Because your application will run and it'll take memory spots and hold memory, other applications can't use that memory. And if your program stops and you haven't told it to release the memory, it could still hold on to that memory location. And that's just bad programming. So when we're not using our pointer anymore, when we don't need that memory location out on the heap, we're just going to delete. We're just going to delete the pointer. And that's it. The keyword is delete. When we're done using the pointer out in the heap, your program's over, or you no longer need that memory out in that heap space, you're just going to go say delete, and it'll free up that memory. And any other application can use it, or you can go back to it later. So we need to learn how to free up memory. This takes a little bit of time to get this concept back and forth and a little bit of practice, but we're just introducing this. We'll take a look at some of these things when we do our coding. So that's kind of pointers. They point. They hold memory addresses and they point to that memory address. They're just a variable that holds a data type memory address. It's cool. Now, references. Reference is an alias to a variable. Or an alias is great. It's another name for a variable, right? To the variable, not like another name for variable, but to the variable. You must initialize these on declaration. You can't do like you can't declare it and then just assign it later. Okay, you have to assign it its alias. You can't say you are going to have an alias, another name, and then you can't say of somebody else. I'll name you later. You have to say your alias is this. And then that's what we're going to do with our references. Only one time. You can't, like pointers can point to different things through the lifetime. Once that reference is set, man, it is there. It stays. You can't re-reference something once that reference is there. It stays. Okay? Got a witness protection reference, right? So it's going to go by another name. The government knows it as one name, but we're going to know it in society as another name. Let's take a look at how these are built, because they're pretty cool. Now, we had that back in a few slides ago, we had our pointer being assigned the address. How do we give it an alias? How do we say, hey, you are going to be the same thing as this variable? Well, here's what we do. Integer, because num is an integer. So you're going to say integer, address of, the name is ref, num. Now, whenever I use the keyword ref, it's going to, let's say when I do num, integer num, right? And that equals 10. Okay. Now, I did not go to art school. So when I do this, what happens? The compiler goes out, it grabs a block of memory, x35z, and it stores 10 inside of it. And then this is num. And num knows this memory address, and it's holding on this memory address, and it sees that. Now we're just going to take reference, and it's going to give it the memory address of num. So now reference, now ref is also, I know it says point, but also knows this memory address. So if I do anything to num, if I do anything to ref, it changes what num's value is. Okay? So let's say num has a whole bunch of popsicles, and nobody knows where num keeps them. So if num wants to give somebody a popsicle, num's got to go to his special freezer and give it to somebody. Now num has a friend called ref that he trusts very, very much. So he tells ref, hey ref, these are where I keep my popsicles. So now ref can just go and get popsicles. So ref can change the value of his popsicle stash, right? So he must trust him very much. So that's what we mean by referencing another variable. I can't reference a number because the number hasn't been allocated into memory. So it has no memory address. A variable has a memory address. I hope I'm just not confusing. It's kind of fun. How do we use it? We can use it just like an original variable. It's an alias, right? We can use it just like original variable. So my alias, let's say my rapping name is Vitamin D, because I'm full of sunshine. So I'm on stage and you see me and you say, hey, Professor Sarlo, and I look up and I'm like, no, I'm Vitamin D. And you're like, no, you're the same person. That's what this is. So if you use the alias name or if you use the regular variable name, it's going to be the same memory spot. Any changes made to the reference affect the original variable. So now ref is 10. Now what variable is referring to num is now 10, just like we had in our popsicle example. We can change the integer value of our popsicles. We did this. Now, it's hard not to do functions and not talk about passing by reference. But because we can pass the memory address, remember, memory address? Because we can pass the memory address, we don't have to return value. We can increase the scope or the visibility of certain variables just by passing the address into a void function. So if I pass num into here, what am I doing? I'm getting an alias. I'm not creating a new variable. I'm going to the memory address. And then I can just say x equals 10,000. Right? Now, when I go back into my main, num is going to be 10,000. No return value. I just said, hey, go to where I keep all my popsicles and put in 9,000 popsicles. And now I have 10,000 popsicles. You didn't have to tell me. You didn't have to get another freezer or anything. You just loaded me up. So that's kind of cool. I think it's really cool. These are fun. We're going to look at the examples on the next slide after this, because this is all we need to talk about on this. Okay? Just remember, pointers offer flexibility but require explicit memory management. If you declare a pointer with a new integer, an integer pointer foo equals new integer, you're going to have to delete foo later. Okay, you can't leave that foo allocated. It's bad for your computer. And it's just bad programming practice. References provide simpler syntax and safer in some contexts. You'll see this when you become better programmers, but sometimes when you can just share the memory address, it speeds things up, and you're not creating multiple variables, right? You're not passing in multiple variables and moving things around and creating memory leaks and doing things like that. So working with memory is a really important thing when you start learning C++. But don't feel like you have to know how to work with memory on your first year of C++. This is what you'll practice later on. Now Java, C#, they all have what they call garbage collectors, and they go around, and if something's not being used, the garbage collector gets it. C++ new libraries kind of do a decent job of it, but we still should know the fundamentals of new and delete. Okay. So what we're going to do next is we're going to bounce over to Visual Studio, and we'll look at some different codes on declaring pointers, using pointers, dereferencing pointers, using references, and passing by reference one more time. And a little bit of arithmetic, pointer arithmetic. All right, so I'll see you over there on Visual Studio. All right, here we go. We're going to get going here on pointers and reference. And let's just kind of jump into it and see what we got going. And we'll run this. We'll explain it. We'll run it. And then I'm going to bounce us over to a website that I use that lets us visualize the allocation of memory and stuff, so we can discuss new and delete that we talked about with our pointers and allocating memory. So let's look at our Visual Studio right here. I'm not using a vector. I haven't included, so I don't really need it. But big deal. And no, this is not called void. It's called change value. It's a void method. It doesn't return anything. But what we're going to do is we're going to put 100,000 into a variable and give that variable access without having to return any value. It's our popsicle theory that we talked about. I declared a simple array of 5 numbers, 1 through 5. Again, 1 is at the 0 index. And then this is just, we're going to use this for our pointer arithmetic. And I declared a pointer right here. Some people don't like this declaration of pointers because they want to set it to null, so it's not just hanging out there. But I'm okay with it. That's going to be your instructor's stuff. But I'm okay with just assigning the pointer. So what do? We have an integer pointer. What does this mean? PTR is our variable name, and it can only hold addresses of integers. Now we have a simple whole number, and that's just an integer. This is just a plain old variable called whole number, and that whole number is 100. Now, what do I have? I have a variable that gets allocated a memory location when it's compiled. So what do? I'm going to make reference to that memory location. So now I have an alias to whole number. Anytime I call reference, it's going to be this 100. It's going to be the whole number, that's this 100. Notice what I do, I just said, hey, reference, you can go see what's in my memory location. That's it. So we're going to print that. It's going to be reference to whole number. And then we're going to print the whole number variable. Now, because I have memory addresses, I can declare a pointer called memory address. Remember, an integer can only hold integer memory addresses. Well, whole number is a integer, and if I want to see the memory of whole number, I use the ampersand in front of it, the address of. So now memory address is holding on to the address of a variable. So if I print it out, it's just going to show me the physical address on my computer where memory address is. If I want to peek inside of that memory address, I'm going to deallocate it. Now, everything kind of goes this direction, right? So what I'm doing is I have the memory address. I'm just going to use the deallocation to look into it. So it says, hey, what's under that memory address? Remember, my reference is the whole number. So reference and whole number are both looking at the exact same memory address. I'm going to change the value of whole number just by changing the value of reference. It's an alias. So it has the exact same access as whole number does. So I'm just going to give reference hey, go change whole number to 300. So when I print whole number out again, I printed it out here first and it was 100. If I change it to 300, I'm going to print it out again. It's going to be 300. Okay. Now my pointer arithmetic. Remember I declared a pointer called PTR, and it didn't have anything stored in it. Well, in order to store something, I'm going to take the address of the very first index of my array. This is how we do pointer arithmetic. So if I look at that, now pointer is holding on to the first index of my array. If I want to see what is underneath that address, I deallocate that with a star. Now I'm taking pointer, which is my thing that I declared up here, and instead of just being the very first memory address, see how I made the first memory address? I'm going to say first memory address, I want you to go 3 more over. So this should print out 1. This should print out 1. Then I move it 3 more over. 1, 2, 3. And this should print out 4. It just moves along the physical memory, however many times we tell it. If we tell it to move too far, you'll get an out of bounds error or a fault exception. Okay? So now I've started at 1 and I moved over 3. Okay? And then I'm going to change the value. This is my pass by reference. So what did I do? I have whole number. We've done a lot with whole number. Started off with 100, then I went to 300. Now we're passing it into my method, and it's going to get the address of it, and it's going to go to the address, and X is going to know the address because we're telling X, hey, here's the address of whole number, and X is going to take the 300 that's in there now and replace it with 100,000. And let's take a look at each one of these after they compile. Ideally, I get a successful build. Okay, so step through really quick. Reference of the whole number, right? That's a reference of the whole number, ref. What do we do? That got the address of and took whole number and took the address of and stored it. Now 100 is the exact same, 100 is whole number. This is the address. See, I took the whole number, I stored it into a pointer that holds memory addresses. So that is the address of the whole number in a pointer called my address. So that's my physical address. Okay. Now, if I dereference that, I just put a star in front of it, and that lets me dereference that. So there we go. Now I can see what's inside of it. Well, we are referencing this 100. There's the memory address that it's at. This is the 100. I went ahead and I changed it. Reference equals 300. And then I printed out whole number. I didn't print out reference, I printed out whole number. Well, what did it do? I used reference ref to change the whole number to 300. 1 is the first index in my array, right? Because my address is pointing to the very first index and I'm dereferencing that, so I see the value. 4, using pointer arithmetic, 1, 2, 3. So 1, 2, 3, and now I'm at 4. Using the arithmetic to move along the array. I passed in whole number that was 300. Notice this is void, right? Normally in scope, if we created a new variable, we'd print out X, but it wouldn't change the value down here because that would be passing by value. But here we're passing by reference. So by passing by reference, we're passing in the address, so it can go ahead and change that value. So this is the code. Pause the video or whatever. Get some of this typed in, right? Play with this stuff a little bit. Let's take a quick look at another site that I love. This is my visualizer. I use this to visualize Python, JavaScript, C++, Java. I don't do as much C as I'd like to. So what did I do? I created a pointer called PTR, and I'm using the keyword new. And the stack is a memory location that's very, very fast, and then all functions get put on the stack. Well, the main is a function, so it's just going to be built on the stack. All these things declared inside of here are built on the stack. The heap is the physical memory outside the stack. New is going to create a new integer pointer in the stack. Whole number is going to be created here. And notice pointer is here, but we're allocating outside of it. We're going to reference whole number, and then we're going to assign the pointer 300, and then we're going to delete the pointer. Let's just look at some memory allocation. So right there, I just, my pointer allocated memory out into the heap. So now it's saying, okay, you're going to go out in the heap and find it. So the only way we can find that value is with a pointer using new. So new went out and declared a whole new memory location. then I'm going to store 100 inside of my whole number because it's just right there. It wasn't accessed, or it didn't declare or any variable or allocate any memory outside on the heap. Okay, now remember my reference? Well, it's a pointer to the integer. What is my reference going to reference? The whole number. So that's my alias. See how reference is like saying, hey, me and whole number, we're like close. We share everything, right? Now what am I going to do? I'm going to put 300, not here. I'm going to put 300 into this. So now 300 is out there. How do I find this in the heap? Well, I have to use PTR. PTR knows where it is. But let's say I'm all done using 300 or this memory out here. I delete it. And look, it's no more. Okay? It's a null pointer. So, big concept, I know, but just practice. Just play with these a little bit. These are things that you have to work with to get better at. They're not initially intuitive, but man, if you really can understand memory and how to allocate and how to delete and how to manage your memory, you will become a very sought after software developer or computer scientist. I promise you that. All right, we're going to talk about objects next, and then we're going to build our own little application. We'll build a get rich quick application, make us all millionaires. All right, talk to you next video. Bye.